made it a point to bring it to me and say, here, these are yours.
Right.
You okay? Okay, this is the second session of the LSR working group. We have just a couple scheduled presentations, and then I guess Bruno might not be able to come. So I don't know if we want to, if he's not going to come, I don't know if we'll do the discussion of the flooding. We probably won't. So I'm gonna get started with this. No, I'm gonna sit here. I think, or maybe not. Now that I got the clicker, maybe I'll stand up.
Yeah, it works. Wait, let me do. So there's the note well again for anybody that wasn't here last time. It talks about that everything you say and do and everything is owned by IETF here. It's not possible? Yeah, it's weird because I can hear myself echo in the speaker, which is why I'm not like registering that. Okay, talk straight into the mic. Okay, AC, you're up.
Can everybody hear me? Good. No LSR working group meeting would be complete without a presentation on Yang. And not to disappoint anybody, we're going to have one. Okay. The first one we have a few models, is the segment routing for OSPF and ISIS both. There's been a few updates based on requests for these are configurable values for the adjacency SIDs. They've been added under interface configuration in the base model. And I think we should start collecting, start the reviews and get going on this base model. As you know, there are some additional Yang models on segment routing for SRv6. So we probably should get this one going. The next model I'm going to cover is this one I didn't ask for working group adoption last time, but I introduced it. This is the model for the extended LSAs. As you know, we have OSPF v3 now has extended LSAs in addition to the legacy LSAs that have that are fully TLB based. So this model adds all the augmentations necessary to support the extended LSAs. One thing we found is it wasn't really consistent with the base models because we had all these identity refs and we had discussions with the co-authors of the base OSPF model, Derek and others, and we thought, well, we should make it consistent, and we came to the conclusion that we really don't need an identity ref for the type because the container is the name of the LSA type, so we just removed that and just made some editorial changes. Ying Zhen did a good job. She looked at it, got another set of eyes looking at it and making these updates. So we think it's ready for a working group adoption call. We'll take it to the list after the IETF. Has anybody, I know the people that have done the SRv6 Yang model have looked at this because they extended it. Has anybody else looked at this model, the extended LSAs? Not a lot.
Yeah, but I think the bar's pretty low to push these forward.
No, Tony's lying.
They augment models. They don't change the protocol.
Right. Yes. Exactly. Yeah. We'll start the working group adoption. Hopefully, generate some more interest other than the authors and the authors of the documents that are dependent, models that are dependent on this model.
So Les, you're shaking your head. Do you have objections to pushing Yang models easier than protocol extensions?
No, I was just thinking any draft I write now, I'll just put Yang in the title.
There's one pet peeve of mine. I do not like when people spell Yang not all in capitals, because it is an acronym, and it's not capital Y-A-N-G. That's just an aside. But yeah. Okay, the last one are these. One comment, when we were doing the base model, it was a moving target for both OSPF and ISIS, and Yingzhen is working on an ISIS equivalent of this too, where we were missing features. So we started adding, we looked at the RFCs that have been done lately, and we started this draft. I mean, we'll probably add more to this, but right now, here's kind of an analysis of the ones that we have. The two-part metric, I had made a real, I think, based on a requirement for somebody who said it here, I had made a quick effort to add it to the base model, but I realized I hadn't added everything, so I'm going to remove that the next time I update the base model based on some comments we've got. We also have the graceful link shutdown. That's a new RFC. We're going to add this augments the model to add that, and link local signaling for local interface advertisement. That's also included in this new draft. And we're going to probably do most of these that are that aren't included. Any of them that aren't included. The one that I think we'll do, we're going to add seamless BFD. Not the transition, probably not that. That's an informational draft. And topology transparent zones experimental. Now for GMPLS, we're not going to do the full GMPLS. We're only going to do RFC 4203. So all the optical stuff, I haven't talked to the CCAMP, but I see that as them doing the all the optical extensions, and they're too numerous to mention. Maybe I should send a formal. We should communicate with the CCAMP chair. Said we're only going to do RFC 4203 for GMPLS. Two-part metric. We got an augment of the sub-TLVs with both the MTID in OSPF v2 and the metric to the network, the second part of the network. We also have the configuration. We have for each interface enabling two-port network and two-part metric and specifying the cost. Now, additionally, there's one piece that we don't have here, but we're going to add is there's a capability bit that says whether or not you support it in the functional capabilities. That's also in the router information LSA. If you remember that one, that's RFC 7770. Graceful link shutdown. We enable it on the interface, add that configuration. Then for the read-only operational state, we're adding these sub-TLVs. Okay. And finally, this is for OSPF v3. It's a little different because it's different LSAs. OSPF, this is also dependent. Now that we have the extended LSA draft, we can complete the specification of the Yang model for both OSPF v2 and OSPF v3. And finally, this link local signaling, we just have it enabling it in configuration right now of the local interface ID. And that's available elsewhere in the model, so we don't have to add a separate augmentation to the actually, it's in the link local signaling. We don't have, well, we have the link state database. We don't have the packet formats in operational state, so it doesn't impact. So all we need is the configuration for this one. That's all. But we'll request, probably do some more, make sure we've got everything that we missed in the base model in this, or everything we intend to do before we request working group adoption. But we wanted to get a start on this, especially if people looking at the base model, they say, oh, you're missing this RFC in the Yang model. And Ying Zhen is working on a similar draft for the RFCs that were missed in the ISIs. Comments? Remember, Yang is all uppercase.
Okay.
Ketan Taravlikar, Cisco, presenting OSPF V3 SR V6 extensions on behalf of all the co-authors. So this draft was actually published before London, but we have never really presented this. So this is kind of probably the first time. But the ISIS draft has been progressing, and that's where most of the discussions and reviews have happened. And now it's adopted by the working group. So we thought it's time for actually presenting this draft, and this version 04 is aligned with the ISIS draft version 02, the working group version 02. So wanted to focus this presentation on more of the OSPF V3 protocol encoding aspects. The rest of the protocol operations are very similar with ISIS. So the key components for this extensions are first the SRv6 capabilities and the algorithm participation. So the new TLV is really for the capabilities. Then there are new MSD types introduced for SRv6, and that's applicable here as well in OSPF v3. Now, for advertisement of the SRv6 locator and as a SIDS associated with the node, a new LSA type is being introduced for the SRv6 locator. And under that new LSA type, we'll have the locator and the other SIDS being advertised. So go into the details of that. And then for the SRv6 SIDS associated with adjacencies, we have new TLVs under the links, under the link they're basically new link attributes TLVs. So starting with the capabilities, it's a new top level TLV of OSPF v3 RILSA, and it advertises a support plus some capabilities. For the algorithm, the existing SR algorithm TLV is going to be used for OSPF v3 as well. For the MSD type, we have a few of them that describe the nodes capability for various SRH operations. So these have been defined already in the ISIS draft, and the types are shared between ISIS and OSPF. So those MSD types are applicable in OSPF v3 as well. Next, we come to the SRv6 locator LSAs. So with SRv6 locators are similar to prefix reachability, but they carry the additional algorithm context, and we have the SIDS instantiated under the locator. Now, earlier today, we talked about the scenarios where we may not always advertise a prefix reachability for some of the SRv6 locator One use case is for flex algorithm. And therefore, there's a need or requirement to advertise this separately so that they are processed only by those routers that support OSPF v3 SRv6. So that's where a new LSA is introduced. And the scope of this LSA, the S12 bits is determined by the type of the locator. So locators can be intra-area, inter-area, or external, and their flooding scope would be based on that aspect. So this LSA is not really processed as part of the normal OSPF v3 routing reachability. Those existing LSAs are what's used for the computation. The locator is used mainly in the cases of flex algorithm. So under the locator LSA, we have this top level TLV, SRv6 locator TLV, and it looks something like this. We have route types here, which indicate that what is the type of the locator, and the flags are also instantiated here. So unlike in the ISIS case, since the locator TLV is a separate LSA, we cannot reuse the existing prefix attribute flags that we had with OSPF v3 or OSPF v2. So the flags are instantiated or defined separately here. And then we have the metric, which is associated with the specific algorithm of the locator. Then next we have the SIDs associated with the node, like the end SID or the end.op SID variants, and they are advertised as sub TLVs of the SRv6 locator TLV. The SIDs inherit the algorithm from the locator. So this part is very similar to ISIS. The SRv6 SIDs associated with adjacencies are advertised, as part of those adjacency TLV. So they would come under the extended router link TLV of the extended router LSA. And we have the two variants, the n.x and the LAN n.x TLVs. There is also a new there's an optional sub TLV that is introduced for the structure of the SID, and this would be associated with each of the SIDs that are advertised. So would like to request review and feedback from the working group specifically on the OSPF v3 encoding proposal and OSPF v3 operations.
Anybody read the draft? I didn't read the whole thing, so I can only put my hand up this high. I started it. I will review it, though, I promise.
Yeah.
So we've completed all this. No, we have one more. We have one more. We have Shadra.
My name is Shraddha Hegde from Juniper. I'm going to talk about CRH extensions for ISIS on behalf of co-authors. So we have background and ISIS extensions. So the SRv6 Plus is a mechanism for constructing a path through the network using topological SIDs. The difference is that you have what are called as topological SIDs, which are used for constructing the path, and then you have per path and per segment service instructions. So what gets advertised in ISIS is only the topological SIDs. So we have two kinds of topological SIDs, loose SID and a strict SID. So loose SID is used when you have to reach a node, and to reach that node, the normal SPF paths are used. Strict SID is very similar to adjacency SIDs. It corresponds to a particular interface through which your traffic has to flow. So the SRv6 path is constructed using two kinds of, the topological path can be represented with these two kinds of SIDs. And what we're going to see now is the ISIS extensions to carry these two. So this is the CRH capability advertisement. So this, it's a CRH sub TLV. It gets advertised in the router capability TLV 242. So we have type, length, and max CRH length. So max CRH length corresponds to how many SIDs this router can support. So we probably need another information here to indicate how many the size of the SID. So we in the SRv6 Plus we have two sizes, 16 bits and 32 bits. So that's probably needed, but we are also contemplating whether only 32-bit SID would be good enough, so in which case we wouldn't really need the size of the SID in this advertisement. Loosely routed SIDs. This looks very similar to node SIDs in SRMPLS, and they get advertised in TLV 236 and 237. So it has type, length, and per algorithm SID, and you have the size of the SID is represented with the length, and this gets advertised in IPv6 reachability. So the algorithm is the algorithm field here. It is very similar to the algorithm field in SRMPLS. So the SIDs are associated with one or the other algorithm, and that gets represented here in the algorithm field. Strictly routed SIDs. So these are used to send traffic on a particular interface or a particular set of interfaces. So again, it is very similar to the adjacency SID in SRMPLS. This gets carried in 22 or 222 and all the variants of IS reachability. So the it has type, length, and flags and weight. So the flags are represented. The flags have these fields B, S, and P. B is a backup, whether it is capable of protection or not. S represents a set when the same label is used to load balance traffic. So the S bit is set, and P represents persistent. And the weight represents when this SID is used for load balancing. The weight represents what the weight carries the information, what amount of weight should be associated with this particular link in which this SID is carried. So again, no different from SRMPLS, pretty much very, very similar. So LAN strictly routed SID. So we need, for LAN interfaces, we need to mention this information for each and every neighbor. So the same information is carried in the LAN strictly routed SID with additional neighbor system ID information. Again, this is carried in TLV 22 or 222. And the information here carried is flags and weight are very similar to strictly routed SID. That's pretty much questions and comments. Thank you.
So this is really, really new stuff. You haven't presented the base and spring yet, right?
Yeah.
Yeah.
I think it was presented last time. I don't know, Ron. Was it present, the base thing it was presented last time?
Ron Bonica, Juniper. The CRH draft was presented in 6-man last time.
Okay.
Now there is a SRV6 Plus overview that talks about the CRH draft, destination options that go with it, the whole overview. That'll be presented in spring on Wednesday.
Okay, so, good. Everyone wants to understand this, should pay attention to that.
Thank you.
Yeah, just from I think if that goes forward, it would be more than likely that we would accept this. So it's really contingent, like the enhanced VPN work that was presented before. If it gets adopted by the IETF, we'd certainly adopt the protocol signaling drafts as well.
Okay, you can introduce it. Since I'm on the.
Oh yeah, you're a rebuttalist.
I'm on the list.
Yeah, so that concludes all of our scheduled stuff. Bruno, I think you walked in, yes. So we weren't sure if you were going to show up, but now that you're here, I think we should go ahead and continue the discussion. Continue the discussion from earlier. I'm not exactly sure the right format to do that in. Maybe we should pull up somebody's presentation. Would anybody like their presentation on the screen? Are you going to sit that far away from the mic? Okay, so I do, Bruno, earlier you wanted more time to address the comments on Las's presentation, so maybe I should pull that one up and then you can talk to those. Okay.
Bruno Ducan, Orange. Well, I think we should rather discuss the draft on the mailing list. So it's priority, especially that the draft is small, it's 2 pages. But if we have time to discuss,
yeah, I mean, if this seems like a bad idea now,
whatever
then
format.
we don't need to do this.
I'm open to discussing whatever format you want.
Yeah. Since AC Lindum, speaking as contributor, speaking as working group chair, I looked to see what OSPF had done in terms of a draft that didn't specify bits on the wire, but did specify this behavior. It was by Goggin Chowbury back in 2005 for different various flooding and prioritized treatment, because OSPF does not have a gap. It's just implementations have done something, and these are a bunch of recommendations, and it was a best current practice. So if we do the signaling as in your draft, then it would be a standards track, but we could also recommend changes without that. But you made the point about the fact that we're violating the ISO standards, so maybe it would be standards track no matter what we do, right?
Yeah, I think it's a good way to address the fact that we have, I don't know, anybody else who's been in the vendor position has faced like these, ICSIA or whatever, like, do you pass these tests? And, it wouldn't be bad to actually have something that says you don't actually have to send it that slowly. Yes. And make that a standard so nobody can put that in your face. I'm not even a vendor anymore. I think that wouldn't be bad. Wherever we go with a solution, I think earlier everyone stated we all want it to go faster, right? So let's get there. I would like to watch the, I don't know if this is the right form here, but the discussion seems very interesting to me, of receiver side versus transmit, I think looking at both ideas, my takeaway was that Les's idea primarily the flow control comes from looking at your retransmit queue. I have questions on that, like, is that too slow? Are we wasting too many resources to let things get dropped first? Which I think your idea is more proactive, right? And so we're not wasting a lot of cycles finding out that, we're flooding too fast or whatever. So I'm rambling.
So
So does anybody have anything they want
if
to
you
talk
want,
about?
I can provide comments on the slides.
Yeah, on the list you're saying, right? Yeah, yeah.
So either we discuss the draft on the list.
Yeah.
Or I can provide comments to the slides from Les.
Okay.
And to discuss that. You want any other?
Oh.
So, okay.
Yeah, you had, I mean, you wanted me to go to
Easy
slide
to-
2 earlier,
to-
so.
It will be easy to point. So slide 2, first comment, the first section is not exactly what is the draft. So if you want to discuss the draft, maybe we should copy paste. The slides say the numbers are dynamically. Actually, the drafts say exactly the opposite. We say we advertising static value. We don't asking for dynamic. So the slides make the opposite claims and then use that claims to say that the solution is not bad. So this is not that's not correct. The draft is not asking for dynamic values for the numbers.
Although, just to point out, Tony did say he was going to differ with the authors, and he thought that might be a good idea.
Yes, but I think the slides were commenting on the draft.
I'm trying to start this.
Yeah, but the slides are commenting on the draft, which is not.
So Bruno, one question here. Are you saying that the thrust of the draft's proposal is that you should assign different flooding speeds to different interfaces as a static configuration?
We'll come to that. Different flooding speed with different interfaces.
But I mean, is that what you're saying that your draft is actually meant to propose?
So the downstream flooding node advertise the value to the upstream. So if you take the point of view of the downstream flooding node, so the one receiving LSP, it can advertise the same value to all interfaces. If you take the other point of view, which is the upstream, the one sending LSPs, it may receive different values from different neighbors. So what is your perspective? But it can.
I'm asking, we've got N routers in the network, each of them with neighbors.
Yeah.
Are you saying your draft is proposing that each router, whether it's done from the transmit side or it's done from the receive side, I don't want to debate that at the moment. Are you saying that operationally you want the network to run where different interfaces use different values for flooding speed? As a static status quo.
Short answer is yes, but you have a slide on that and we can discuss that. And it's already available on implementation, including your implementation. You can configure different LSP pacing per interface, iOS 6e. So
Yeah, and I guess the point I want to make is one of the major points that I'm trying to make in my presentation is that's a bad idea. And the fact that we're doing it today doesn't make it a good idea.
we can discuss that. But this is another slide.
That's a great discussion point because I think I disagree with you, Les. I don't understand why we shouldn't just flood as quickly as possible just because we have, I mean, think about if you had a 28.8 modem link, right? Or, some slow satellite link. And then, I mean, are you really saying we should pace the entire network convergence based on that link? I mean, I think we should go as fast as we can.
Tony Lee.
Just one.
So Les's point, I think, let me restate this to see if I understand it, is if we flood irregularly, some nodes have all the data and some don't, and then we all go off in SBF and we're going to get garbage, right? It's going to cause micro loops. And so,
Right.
so in an ideal world, if we could, what we would do is to flood uniformly everywhere so that everybody gets all of the LSPs at exactly the same time. Okay? Now, I don't know how to do that without invoking dollar deity. So what do we have? Well, the only mechanism that we have at our disposal right now is hop-by-hop flow control. And that gives us the capability of going fast on some links. Now, I don't know about everybody's architectures, but our box happens to have tons of bandwidth now, and the CPU can't possibly ever keep up. Okay? We're never going to get the CPU power to keep up with that incoming bandwidth. And so we're always going to be in this situation where we can go way faster than we can actually absorb. Okay? So we don't want to generate too much stuff because we're going to, link bandwidth is no longer the issue. It's how fast can the receiver absorb it. And the way to make forward progress on this is to have feedback so that the receiver can tell us how fast it's absorbing things. Right? This is exactly the same problem we've solved with TCP, for some definition solved.
Yeah, and I mean, that to come back to my point from earlier, earlier group, this wasn't a problem. This was assumed to not be a problem because L2 was going to handle it. And so when I think about it in those terms, right, like in other words, I can blast it as fast as I want on my point-to-point link, and it will be absorbed by the neighbor at that speed, and L2 will handle it. That models to me like a flow control situation on a point-to-point link, not on a domain-wide value, or it's going to go as fast as a point-to-point, and it's supposed to all be reliably sent unpaced, right? So that's why I keep thinking that it is correct to look at it from an interface level.
So I think the point I'm trying to make is that if you have a network where every interface that's used for ISIS flooding is not capable of sustaining the same flooding rate that's necessary to keep up with the LSP, the rate of LSP change. And I don't think we're talking here about the continuous, I got to send thousands of LSPs every second all the time, because that network is never going to converge. Okay? But during the periods where you have change, when you need to flood LSPs, if you cannot do that on the same rate on every interface in the network, then your convergence is going to suffer. That's the key point I want to make. Flow control is not going to solve that problem. The only thing flow control is going to do is temporarily slow down on a particular interface where you're having problems. Okay, that might be a good thing in the short run to allow, if it's a transient condition and this box is going to recover, and after that it's not going to have a problem, great. But if this happens consistently, when you get a convergence event in your network, you have a problem. And I think we've demonstrated this years ago with inconsistent SPF values.
So in other words, ISO 10589 is broken.
I don't know that we need to debate that. If you look at 10588, strictly speaking, it says nothing about point-to-point links. And
it says send them as fast as possible.
It doesn't
and you're saying that that's broken.
It doesn't actually say that. The only thing it says is what the retransmission timer should be. It doesn't say anything about how fast you should send it. But I don't, we don't need to debate whether 10589 was prescient about all of this stuff or not. We need to decide
the reason
the right thing
I'm
to
framing
do.
it like that because that might be an interesting way to approach this, and address your point, right, of faster convergence.
I'm not talking about faster convergence, I'm talking about consistent convergence. Because if one part of the network converges faster than the other, we have a problem.
By convergence,
Okay.
I mean the network is all agreed.
John Scudder, Juniper. I keep getting stuck on Les's claim that if some interfaces run slow and some interfaces run fast, then the network will be in an inconsistent state. That's provably not a generally true statement, and you can prove it very easily by sort of prove. Earlier today and in previous meetings, we have been talking about this flooding reduction proposal. And what's a flooding tree? A flooding tree is just, or a flooding topology is a topology where some of the interfaces are set to flood fast and some of the interfaces are set to flood at zero speed. And nobody has yet complained, as far as I know, that the network will get into an inconsistent state. So I understand that there are certain cases in which having interfaces flooding at different speeds will result in badness, but I don't think it's as bad. In fact, I'm sure it's not as bad as Les is making out.
So the specific use case that we should probably think about is where we have a large burst of LSPs that we are injecting at a single point in the network. Okay. Let's say, ballpark, we've got 1,000 LSPs, we're dumping it into a 10,000 node network at one point. And this can happen because of the partition that's been healed. Now let's suppose we've got one node somewhere in the network that's slow. Do we pace everything to match that slowest neighbor? We could. If we have this giant thing pacing out 10 LSPs a second, it gradually will work. And depending on how our SPF timers all work out, we might not even generate microloops. But somehow I don't think that's going to happen. The alternative thing we can do is to slam everything into the network as fast as possible, because we're seeing LSPs fly by, our SPF timers keep getting deferred, and eventually slow node catches up and the world has completely converged. I think that's about the best that we can do.
AC Linda, Cisco Systems. I just like everybody to consider that some of the more modern IGPs don't have this inter-packet gap, and we haven't had this problem. Now, I had an implementation at one point that just used the scheduling within a process, and what we did was only send one packet, one link state update in every scheduler round, and it worked fine. The problem we did have was with LSAs that got too big and we got into IP fragmentation and reassembly. Now that caused problems once you got LSAs that, that were over that. And OSPF v3 solves that problem, but unfortunately it's not even probably a 10th of the deployment of OSPF v2. So I'm not sure that adding this complexity is really needed, with modern routers. We haven't had it for 25 years. Maybe it's a nice little mechanism, but do we really need it?
So you're saying just send them as fast as you can?
Send it fast as you can within the constraints, and things will. Now, if you have a really poorly designed network with a tiny little router at the core and big routers feed into it, you could come up with a pathological system pathological situation or topology where this breaks. But do people really design networks that way? I think if they did, we wouldn't have been able to go this long.
I see. You're saying that we don't need any form of flow control.
I think it's implementation, sender-based implementation wise.
So,
you just.
How do you know that you're not going to overload your neighbor?
You don't. You just. But if you do, you need other mechanisms. I don't think flow control is the right. Flooding reduction is a good idea. I don't necessarily think this is.
But it's orthogonal to floating reduction.
Yeah. One thing, and maybe you have the wrong parameters here. All LSPs aren't created equal. Some are big, some are small. Maybe you should be doing packets.
It's also orthogonal to prioritize. But
maybe you should do packets, not if you're
going
to do this.
But
ISIS, they're pretty similar.
I know. OSPF.
Yeah, I think your head went to LSAs.
Yeah, right.
do you also think we should remove a flow control for BGP, or it's just ISIS? You say any modern
TCP, right?
Yeah, but we can also.
We do have protocol. We do have a proposal to run ISIS over.
Hank is on. He's in the queue. If you look online. So I was going to say to that. To use John Scudder's point, I think we have demonstratable ways to overflow routers, right? That's why we're doing the dynamic. I've seen it personally where I've blown away routers. If they get too many links going into it and you don't have any flooding suppression, you can kill things quick. So I mean, I think we have to do something. I don't think we can just-
But we do have mechanisms to control, pace the
Yeah.
origination and
Yeah.
stagger the originations and things like that. And those are all good.
Yeah, my suspicion is the dynamic flooding stuff isn't enough because there's not enough feedback to use it's not a control loop, but less is waiting.
Stefan from Orange. I'm just wondering about the exact value added of using a protocol extension rather than just configuring the timer on the sender part.
Okay, so you can configure the timer. So it doesn't change the discussion that we are having. It's orthogonal. The issue is that what value are you going to configure? So you have a network. Are you going to? You should configure the value which is correct for your neighbor.
Yeah.
So you should configure different value for each neighbor.
Potentially, if this could be a target design, single value for all neighbor or dedicated value per neighbor.
Yeah.
Depends.
So anytime you, yes, but anytime you change the configuration of your network, so replace one node by another one or remove one node, add another one, you need to change the configuration.
Yeah, but we are already doing it for metrics and so on. So.
Yes, but we're not doing it for LSP flooding.
No, but we are doing it for some nodes that are supporting RSVP, some nodes that are not supporting RSVP. This is something that is manageable from an operational point of view.
So the fact is that we don't do it.
So do you think, so your idea is like if you had exposure to LSP drops, for example, that your management system could go see that the LSPs are being dropped between these two neighbors, and then I could, the management system would then change the pacing on that interface to bring that number down.
Yeah, but what I understand here is the value that you are configuring on the receiver is static anyway.
Right.
Yeah.
So,
but it's static. It does not change over the minute or hour. But the downstream node can change depending, for example, on the number of IGP neighbors it has. So, for example, if it can process 10 LSP per second in the control plane, it can divide by the number of IGP adjacencies that it has. And that value can change anytime you change the topology of the network.
Yeah, that's really implementation dependent, and you can always face some race conditions when the computation that it will try to do will be wrong, and you may face some issue. So
now,
the discussion we had in the corridor, I thought that it was a configured value that you had on the receiver.
It's better.
Dynamic.
On the receiver, it shouldn't be well, you can configure, but it's better if the vendor say, this is my capability.
Yeah, it's static.
Yeah.
Yeah. So if it's static, you can configure it statically on the other side.
No, because it can change depending on the hardware. So if you improve the hardware, you change the value. Depending of improvement in the software.
But this can be part of the operational process of remeshing and so on. I'm not telling that it is bad. I'm just telling that it's manageable also by just doing configuration.
Yes, but the fact is that even with very high-end networks, just like the one you have, we're not doing it. So for networks which are not that expensive, I would say, there is just no chance that we do it. And we have very conservative flooding because everyone uses the default value, which are very conservative.
To have conservative values, because maybe in most of the cases, if I have some node failures or multiple node failures, faster value will work fine. But we have to think about the really bad case where, for example, all the LSPs for all the nodes in the network are refreshed or purged multiple times in a very small manner, because it happened in some of our network. When you have some purge, refresh for a very long duration.
I know, but
your routers need to be able to sustain this.
I know, but your comment is applicable whatever the value we choose.
Yeah, exactly.
Okay.
But I'm not. But
so
when I hear that we need to fast as we can, we still need to be.
No. I'm not saying as fast as we can.
No, but
I think we need to exactly take into account the capability of the receiver in order to not overload it. So not blindly firing packets. So
Thanks.
David Lamparter. I would like to take Les's position/argument and turn it on its head. So we do what we do know is that we get all kinds of problems, microloops, whatever, if we have SPF runs either not synchronized with each other with completely different timers or with inconsistent LSP databases between the routers. Now, if I have some large change on one router and it has a lot to push out, I'm starting a race against the SPF timer. So I have a set amount of time to try and get the network to have a consistent LSP database throughout. None of the intermediate states with some information flooded but some other information not flooded is really going to help me, because I have no assurances that this intermediate situation is free of problems or anything like that. So from that perspective, the only thing I can think of is I really want to have everything flooded out as fast as possible. So I just don't agree that trying to slow everything down to a similar pace or trying to synchronize somehow by controlling the rate of flooding is actually helpful. It's not the rate of flooding that is causing the problems. It's the dissimilar SPF runs that is actually going to create the problem. And I don't see how to avoid this otherwise. So we are in 100% agreement. Well, I guess so. But my solution is to flood really as fast as possible. I don't even care about not. I rather care about being able to get missed packets again. So for me, the flooding couldn't even be fast enough. I rather have the receiver drop something and ask for something to be resent or some approach like that. So for me, I really want to err on the fast side.
You know what the retort is to that?
Okay, well, in no spectrum of this universe may I be classified as young anymore. So I just want to point out that there is some certain amount of commercial value in converging quickly. And people are going to push for this. And people are going to push us to flood faster. Okay, this is coming, and we're certainly feeling it. I'm sure other people are too. We have to do something. If we just depend on timers, we're going to end up setting timers to be very conservative. And that's going to fly in the face of that commercial values, and people are just going to then start using more and more aggressive timers. And that's going to yield bad things. You're going to swamp input queues, and then we're going to see lots of LSP drops, and then people are going to be very unhappy when bad things happen. The right thing here has to be to maximize good put. And again, the way to do that is dynamic feedback.
I don't know, Bruno, how much effort you want to put into this, but I think that it might be cool to actually maybe even find somebody at university or whatever. You could model some of this stuff, right? I mean, some of these things we're talking about, we are not proved yet, right? Like I think there's some intuition going on here with what we're saying. You know, if some of your points, or it might be interesting to actually be able to show one way or the other what converges the fastest, right? And you know, have little knobs where you can put and say, you know, drop this many, right? Like, you know, between the two and model that. I would certainly be very interested in seeing the results of that with the different solutions, right? With an idea of being able to pace from the receiver, or, you know.
So there are different aspects. The first one is LSP pacing. This is something which is implemented and deployed by everyone. So
right, being deployed by everyone doesn't mean it's the right solution.
No, I'm not saying it's the right.
It seems to have worked. Right?
Yeah, but it could be even better if the parameter would be correct. Just not just a default value selected 20 years ago,
Right.
or at random. So.
Ketan Talwalkar, Cisco. So I just wanted to, that's a point that I wanted to bring up. What would be the value or the default value of of this thing. We're talking about going as fast as we can. So maybe the default value is 0.
If you can receive at infinite speed, yes,
Right, so
send
maybe
0.
And then that brings up then, because you mentioned that you are looking for it for it to be fairly static, right? So then, but I think Tony mentioned that you would like it to be dynamic. So what's the requirement? If we start with 0, then are we looking at some sort of really the dynamic? So are we going dynamic or fairly static config thing, like what you were discussing with Stefan earlier?
So the draft that we are discussing, we are sending static value. So if you send 0, you should be able to receive LSP at full speed, full interface speed. There is no reason to be dynamic because you said I am capable of doing full speed. So if you commit to be capable of full speed, you don't have to be dynamic. If you're not capable, you should advertise what you're capable of.
Okay. And how do I, as a receiver, how do I even know that I am dropping something somewhere?
You mean the receiver of LSPs?
Yes.
Yes. You don't.
How do I know?
You don't have to know. I mean, I'm the sender, so I'm sending you a packet.
No. I mean, like I start with 0, and like, how do I know that I have been dropping stuff?
No. The current proposal is the current.
You have to know.
No, you don't. Well, you should know, but the current proposal is static.
I mean, maybe my ISS process doesn't even get a chance to run because something else is. I'm just.
Okay, but I am the sender. I'm the one who need to send you LSP. If I delay too much, I'm creating inconsistency in LSDB. And if you drop something, I will know. Right. Because you're not going to acknowledge it because you never received it.
So sender knows. So again, aren't we talking about the sender-based flow control and feedback?
But this flow control is between 2 nodes. So you advertise your capabilities, and then I send as fast as I want according to your capabilities.
Okay, maybe I step back. So I start with value 0. I'm the receiver. I start with value 0. I can handle anything that you throw at me. And then maybe BGP on my router is going for a spin, and I'm very busy. I'm not even maybe able to pick packets or whatever. How do I even know that I'm losing packets? The only guy that knows that I'm not able to process, isn't it the sender who is not getting my act?
So first of all, you should advertise a value that you can commit on. Then second, you're receiving many packets, so said from BGP and ISIS. Well, typically the packets are received by the line card. So you receive all the packets that I sent. It's a point-to-point interface. So if you drop packets, it's typically between the line card and the control plane. You typically have multiple queues. It's a cost issue. I mean,
So I mean,
you should have a cost value which is good enough to match what the advertised capability that you sent.
So I know I can't believe we're running short on time, but can we let some other people in the queue, like Dino hasn't talked yet, and Peter I don't think has talked yet.
Okay.
So let's get them on too.
So I basically wanted to know about this, whether it's dynamically and static. That's from a requirements perspective what we are trying to do. And if we do dynamically, then I would like to see a discussion of actual implementation aspects and how do we take care of it.
So far the draft is static. In terms of value.
We definitely need some feedback between the layers that doesn't exist today in many implementations. You definitely need to do that on the receiver side to be able to support this.
Right.
Thanks, Peter from Cisco. So honestly, if what you advertise from the receive side is static, I don't see much of a benefit not doing it, or what is the benefit doing it from the receiver? Because you achieve the same thing whether you configure on one side or the other. So the other observation, how are you going to find out what is the value you can absorb? I don't know. Honestly, it's a bit of a magic to me to say, well, how fast I can. And
if you, excuse me to interrupt, but if you have, as a vendor, an implementer doing the code, if you don't know what value to configure, how do I know which value to configure with your CLI?
It depends on too many things. That's what I'm saying.
But you have more, whatever the number of things it depends on, you have more data.
I'm going to change these values that I advertise every time I add some more load on the box.
And should I do it? Someone has to pick the value. You have more information.
But then I guess we need a dynamic solution. Well, you adjust the number. It's not static. You need a feedback loop which is dynamic. That I can understand. But you are talking static value. Static value, I don't really understand. What is the benefit of doing it from the receiver?
Even with static value, we have a static buffer or memory. We have dynamicity because you acknowledge the LSP. So I know.
I know that from the sender side, right? I know I'm the operator. I know what is the receiving side. Anyway, we can argue that. That's just my point. And the other thing is, if you are doing it from the receiver side and you are doing dynamically, you can get drops even before the packet comes to your IGP process. You're never gonna know about that. So how is this going to work? Well, basically we are going back to the sender has to adjust because he only knows. Right?
You don't know when you drop LSPs?
You can drop before it comes to ISIS.
Yes, but
So how do I know? How can an ISIS process send you a feedback saying?
You know that you have a queue between the line card and the control plane. You know that the queue has overloaded. You know what the priority, so it's possible it's an LSP has overloaded.
That queue, I don't care about what packet it is.
But you could do, this is pretty easy to do, Peter. I mean, it's pretty easy to have your line card tell you that I dropped some CLNS packets of this type.
Well,
no, but by the way,
You don't need to know what got dropped. You only need to know what you received, right? The way you do this is acknowledge what you've accepted. And PSNPs are perfect selective act. And then you can also tack on the TLV to say, this is what buffer space I can see left.
Yeah, I just want to say something that typically the socket or whatever implementation, the equivalent of the socket is much slower than any of the other nexuses within the system. So that's where they're going to get dropped, I think. Yes, I agree. You know, you just need more interaction than exists today.
This is Dino. Sorry, coming late to discussion. I don't think you're going to help anything because, and what I've heard so far in the line was send as fast as you can. I don't really know what that means. Sending as fast as you can means don't put in a delay timer to send it slower. When you get the CPU, as soon as you can, the process gets the CPU, send it. Don't do anything in any code logic to slow it down. That's fine, but that doesn't mean it's going to go as fast as possible. Don't forget we have hardware and a data plane that's shipping packets out on these output queues, and you're going to sit behind these output queues. So convergence and tail drops are going to happen quite a bit. And so if you try to say slow it down, then you have to trade off convergence. Okay, so the only way to slow it down is to have the whole network receive exactly at the same time. So I'm going to follow this up with a story. In 1987, DEC implemented a trading system on Wall Street, and they wanted everybody to process this trade exactly at the same time. So they knew they used global clocks, and they sent global clocks around for a particular instrument trade. And they said, in 1 minute from now, I know everybody will receive the packet, even including with losses. 1 minute from now, that everybody will sit, this packet will sit, or this trade will sit in my input queue for X number of seconds, but I can't process it until the timer fires. Then everybody will process the trade at the same time, and then we have fairness, right? We can't do this in a link state protocol because convergence will be atrocious, right? So you have to send as fast as you can, and the only way you're going to be able to get best performance out of your link and in your network is that you have to dedicate some of the output link for control traffic so you don't have the needle in the haystack problem. So you have to configure the output link to say 3% of it is going to be allocated to IS to IS, so there's some clear way so data packets won't tail drop these other packets. Okay, so maybe we solved it on the output link, but we don't know what's going to happen on a multi-access network that's implemented with switches that does your multicast for you. It could be dropped anywhere there, and we have no guarantees on reception. So bottom line of my comments is you can't control this. I think we're doing the best we can right now with no new mechanism.
Yeah, but Dino, I mean, I think we're going from one extreme to another there, right? Right now, we're sending them very slowly. So, and the tail drop thing, I mean, that's a problem no matter what, right? I mean, either you're dropping your control traffic or you've implemented priorities in your your network processor, because I don't really count on my ISIS packets getting dropped because I'm forwarding traffic. I mean, we solved that, right?
They will be tail dropped if there's a lot of traffic. And by the way, a lot of that traffic is going to black holes because of the topology change, right?
Yeah,
So
but that's why we have priority on the MPU.
Yeah, that's good. Yeah, but there's also giants that are going out, 4,500 byte MTU packets that are going out that you're sitting behind. And if you can't get the link, you're going to be sitting in the queue. And your other ISPs from the 1,000.
But again, if my concern is waiting for a 4,500 byte packet on a 100 gig link, then I'm going fast enough. Right?
Well, you made a comment that you're not going fast enough, so I don't know what that.
No, I mean,
you should try to go faster.
No, but right now we're doing 33 milliseconds a packet, right? So comparing that to a delay of 4,500 bytes on a 100 gig
So
link.
fix that simple problem.
Yeah, that's what
I guess Dino's familiar with more modern protocols.
David Lamparter. So if I have an overloaded router in the middle of my network for some reason, and it's only that one router and it's only capped out in CPU for some other reason or something, wouldn't I want the LSP flooding that is coming in from all sides? Wouldn't I want to do something to maybe prefer one of the interfaces so I get the entire LSP database instead of getting the same thing from 50 links?
Okay, let's not make it more complex.
That's dynamic flooding. Yeah, that's dynamic flooding.
So, as already pointed out, right, to make it fast and also to minimize the loss, the key is really the feedback. I think that the problem actually, there is a very nice solution already. That's called TCP, right? So I'm just wondering how much we can actually learn and borrow from TCP to solve this problem. Right.
So first, I don't need to go as fast as TCP or BGP. Any improvement would be. I'm not finished.
That's the minimum step, right? I mean, TCP certainly has lots of protocol machinery. I'm just wondering, I haven't given much thought. Is there a small subset we actually can borrow to address this problem? Because some of this, static, I think the goal is really to make it dynamic, to make it fast, clear, right? If some of this configuration, I think it will be very hard for people to figure out, and also for the number to hold for long term. I mean, if you want to make it dynamic, make it go fast.
So dynamic, everyone has said dynamic so far. I think that should seriously be considered. I also want to point out, unfortunately, it looks like we had a timeout on the Meet Echo. So I think we've lost our note taker. We've lost our remote participants, and we may have lost recording at this point. So we should probably wrap it up.
Okay, last comment. Gaurav Dabra.
Okay, let Gaurav speak.
Gaurav Dabra, LinkedIn. I agree. We should think about dynamic. Because if it's static, you can probably just use an orchestrator to push the configurations down. And if it's dynamic, yes, it does make sense because the whole goal is to converge faster. But coming up with those numbers, and especially the rate at which the network change, and the rate at which you will have to keep changing the dynamic number could be a hard problem to solve.
Yeah. Okay, where's the other blue sheet? Okay, I think I'm glad Bruno was able to get back and we were able to have this discussion. I think it was really useful.
Yeah, I think this is a lot more fun way to spend our time. But...
Sorry.